So we have a sphere, positive charge of 2 times 10 to the minus 8 coulombs. Released at point A, accelerates as it moves to point B. The force is 8 times 10 to the minus 5 newtons. The sphere weighs 0.5 grams, and the distance between A and B is 4 centimeters. So in A, to calculate the work that's done, well, for work, we know we have the equation V equals W over Q. However, we don't have the voltage of the cell. So we need to go back one step further. We need to look at the original work equation, W equals FD. W being what we're trying to find. Force, 8 times 10 to the minus 5 newtons. Distance, 4 centimeters, which we would need to convert into meters, which would be 0.40, so 0.040. Go over to the equation, W equals FD. Substitute in what we know. Plug that into the calculator, and we get a work of 3.2 times 10 to the minus 6 joules. Looking at B, the potential difference between A and B, the potential difference is just the voltage of the cell. So, let's just flip to the other slide here. In B, we need to find the voltage, and we know that V equals W over Q. We just found the work, 3.2 times 10 to the minus 6 joules. Q we were given, 2 times 10 to the minus 8 coulombs. And now we can go to the equation. Substitute in. Pull out the calculator, do the math, and we get 160 volts. Letter C, this one ties together a few things that we've already talked about in terms of work and its relationship with other concepts. So this one's actually an enhanced understanding level question. In order to find the velocity of the sphere, we need to remember that work and kinetic energy are the same thing. So we actually have a kinetic energy of 3.2 times 10 to the minus 6 joules. Knowing that we actually know the kinetic energy as well as the work, we can use the kinetic energy equation, because EK equals half mv squared. The mass for kinetic energy has to be in kilograms. We have 0.5 grams. So we need to divide that by 1,000. And V is what we don't know what we're trying to solve for. Again, you need to look at the formula. Fill in what we know. We can do that calculation on the right side. Gives us 0.00025. We're trying to find V, so we need to divide both sides by 0.00025. Do that up here. On the left, we get 0.0128. To get V now, just take the square root of both sides, cancels off that exponent. And we get that V, if we look at correct sig figs, we should have 1, because of the mass, is 0.1 meters per second.